In this video, we'll be using registers and bitwise operators to control an LED or to blink an LED. This is the normal code which we use to blink an LED. Here we have declared an LED as 7, that is pin 7, and made it as output pin, and we have used digital write to make it high and low. This is the normal code which we use, but in today's video we'll be using registers and bitwise operators to do the same task. Arduino Uno, as it has an 8-bit microcontroller, there are 8-bit registers. By manipulating the data in 8-bit registers, we can control the output pins. So, these pins 0 to 7 are mapped to a port D register. Now let's look what is port D register. See, as port D is mapped from pin 0 to 7, we use DDRD, data direction register, to make it as input or output pin. And port D register, by using this register, by manipulating the data in this register, we can make the particular pin high or low. Now let's use this and write the code. This is the code which uses registers and bitwise operators. In this line, we are using DDRD register to set pin 7 as an output pin. Here we have used OR operator. Let's see how this line works. To understand this line, we need to know about the truth table of OR and XOR gate. And this is the truth table of OR gate. The output is high when any one of the input is high in OR gate. And in XOR gate, the output is high when either one of the input is high and the output is low when both the inputs are same. Now let us understand how this line works. Let us consider the previous value of DDRDB 0101 0000. Our requirement is to make the 7th bit 1. To make this, we need to OR the previous data with mask data. We should be careful while deciding the mask value. We should not change the other bits, we should only alter the 7th bit. So, we are making the rest bits as 0 and only the 7th bit as 1. As we have seen in our truth table, when both the inputs are low, the output is low. When any one of the input is high, the output will be high. So as you can see here, when both previous data and mask data are odd, we get this output. Here, only the 7th bit is altered, rest all remains same. This is the working of bitwise operator OR. Here we have used port D register to make the pin 7 high or low. We have used OR operator. This line toggles the pin 7 from high to low and low to high. Let's see how this line works. Now let us see how this line works. Let us consider the previous data be 0101 000. Now let us perform an XOR operation between previous data and mask data. We should be careful while deciding the mask data. We are considering zeros for rest of 7 bit and only 7 bit is 1. When we perform XOR operation between them, as we have seen in XOR truth table, when either one of the input is high, the output will be high. So this is the output, and as you can see here, except 7 bit all remain same. So the 7 bit has toggled from 0 to 1. Now let us perform XOR operation again by considering the same mask bit. Now as you can see here, both the inputs are high, so the output will be 0, and here it remains same. Again the 7 bit has toggled from 1 to 0. Now let us perform XOR again with the same mask value. Now as you can see, when we perform XOR operation between this, the output of 7th pin again becomes high and rest remains same. As you can see, the output is toggling from 0 to 1, 1 to 0 and 0 to 1. This keeps repeating. And the use of XOR makes it so simple to toggle the pin 7. This is the circuit demonstration. The circuit is very simple. I have connected a negative terminal of LED to ground and I have given the positive terminal to the digital pin 7, and these are power line and ground line. As you can see, our code has worked. The LED has started to blink. This was the demonstration of a simple LED blink using registers and bitwise operators.